All right, guys. So, good evening once again. Um, from what we have done, I think we have one from last.
There is a penal, no?
But there are some questions that I would like us to go through based on this topic, just to reinforce what we would have learned. All right. So I'm just going to quickly just refresh our brains, our understanding on ratio and proportion. So as I said before, ratio is in relation to fraction, right? As we can recall, rationals are fractional numbers. And so when we talk about ratio, we are really relating it to fraction, even though we are looking at shares. Now, in terms of shares, when we talk about ratio, we're thinking in terms of shares. Now, for instance, I may have used the analogy that if you have a pizza that consists of 8 slices, and you decide to share it between you and your friend, now you may decide how much slices you want to give your friend and how many slices you want for yourself. Now, once you have decided how many shares you are going to give your friend, then let's say, for instance, you decide to give your friend 3 slices and you decide to take 5 slices for yourself. Then the share, we would write it as 5. The share would write as 5 to 3. Now, we say that 5 to 3 is what we refer to as ratio. And this over time is written with the symbol 5:3, which means the same thing. So 5 to 3 is the same as saying 5:3. So this is how we actually represent share in terms of ratio and the individual parts. All right. So some of the things that we want to learn about ratio is that we need to be able to make comparison with similar quantities, and we know also that ratio has no units. Now, in terms of, say, expressing a ratio in its simplest form, one of the things that we note is that if we are comparing two quantities, here we have 20 cents comparing to $4, we notice that we would have to convert the $4 into cents in order to be able to simplify this ratio. And so we know $4 is the same as 400 cents. So 20 cents to $4 is the same as 20 cents to 400 cents. And once we simplify this ratio, we can cancel it down just as though we cancel down fractions. And so we would have the ratio of 1 to 2. Sorry, 1 to 20. All right. Also, if we are expressing this ratio in its simplest form, we notice that we have 4 to a quarter. Now, the fact that we have ratios written in this form, we can also write them in the form of fraction, where the left number of the ratio, or the left number to the symbol here, are the left value of the ratio can be written as the numerator, and the right value of the ratio can be written as the denominator. So we can actually convert a ratio in the same sense as a fraction. So if we convert it to say 4 over a quarter, then this will also be the same as saying 4 divided by a quarter. And then we apply the rule of dividing by a fraction. So in this case, we would simply change the division sign to multiplication. And then we flip the divisor. In this case, we would write 4 over 1. And then we would just simplify this by multiply the numerators, we get 16. And multiply the denominators, we get 1. So this becomes 16 over 1. And rewriting it as a ratio, then we would write the numerator first, colon, denominator, which is 1. So this is how we would simplify an expression such as this that we want to express in its ratios in its simplest form. All right, so just recapping. All right, good evening, Ms. Williams and Mr. Authors. All right, we also looked at how to share lengths based on ratios. If we have 2 lengths and they're in the ratio of 8 to 5, and if you're given 1 length, in this case, we're given the first length to be 120 meters, then we are often asked to calculate what the second length is, or vice versa. We can sometimes given the second length and asked to calculate the first length. And so one way that we could do it, we could write the ratio 8 to 5, and we could equate it to the first length in ratio to the second length. Now, in this case, we would have known the first length to be 120. The second length we would not have known. And so if both ratios are the same, it means that we can equate the ratios. We can equate 8 to 5 to 120, 120 to x. And so if you write both ratios in the form of fractions, we would get 8 over 5 times 120 over x. And here from this equation, we would solve for x. And we solve for x by simply rearranging the equation. We do a method of cross multiplication in order to get our denominators. In order to get rid of our denominators, what we do, we cross multiply our denominators with our numerators. So we get 8x equal to 5 times 120. So here you would have 8x here. But in order now to get rid of the 8, we would divide both sides by 8. And when we divide both sides by 8, we would get x is equal to 5 times 120 over 8. And when we do the calculation of the right-hand side, we would end up with 75 meters. All right, and so this would now give us the value for the second length that we don't know, which is represented by the x. All right. Now, another way that we could approach this question is we could use the comparisons of the ratio here. And what we could say is that we know the first ratio on both sides. So normally what we would do, we would take the first ratio on the left and divide the first ratio on the right. So that would give us 120 divided by 8. All right, so we have 120 divided by 8. Now, what we're trying to find is the second ratio, which is the 5 relating to the x. So in order to find what the value is, the second ratio here, we would use it to times it by the 120 over 8. So we times that by the second ratio to get the value of the second ratio. So in other words, x is equal to 120 divided by 8 times 5. And you notice that the calculation would have been the same as before. You will get 75 meters. All right. So that would be pretty much a little shorter than the approach that we took before. All right, looking at this second example here, if we are to follow the second approach, you write the ratio given, 12 to 7. And we notice here we have the second length, which is 21. The first length, we don't know. So we can say this is the same as x to 21. Now here what we do, we know the ratios of the second length. So what we do, we take the smaller value from the first ratio and divide the, so we have the second value of this, or the second share, our second ratio, I shouldn't say second ratio, the second share, we divide the second share that we know by the second share that we have and times it by the first share then we get 7 to 7, 1, 7 to 21 goes 3, 3, 12, we get $36. All right, so we would easily calculate the first ratio by using the second method here. All right, so that would have been the ratio. Now for the proportional part, did we get a chance to go through the proportional part? I'm just recapping what we would have done from last year, guys.
Yes, sir, we did this question.
All right. So also, in order to share any number into any given parts in terms of ratio, we generally first, we sum the ratios together. So we sum all the parts of the ratio. In this case, you would add 7 plus 3, and that will give you the sum of the ratios. Now, we are sharing $1,100 based on this ratio. So when we sum the ratio, it means that the sum of the ratio that we have would be representing the total of what we are sharing. Now, to get 1 part of the share, we would divide the total by the sum. And so 1 part in this case is 1,100 divided by 10. And if this is 1 part, and we are to share it in 7 parts to 3 parts, then if we know 1 part, then 7 parts is just simply 7 times 1 part. So 7 times 110 would give you for 7 parts, and that would give you $770. And now to get the parts representing the 3 parts, then we would just simply times 3 times 110. And that would give us $330. All right. Now it means that if we're in the ratio of 7 to 3, one person, the person who gets 7 parts will get 770. Person who gets 3 parts will get $330. Now, these would be the share after we split the $1,100 into the ratio of 7 to 3. Now, key thing it must be that if we share this into these 2 parts, if we add them back, we should get back the sum. So by adding these, we should get back $1,100. All right, guys. Now, another way how we could actually share based on the ratio here. A second way to do that is to write each part as a fraction of the whole. Let me go back to that. So if we write in each part as a fraction of the sum is 10, and we want to find each part as a fraction of 10. So we could write for the 7 part, we could write 7 over 10 times what we are sharing, which is $1,100. And when we do the calculation, we would cancel, and then we multiply by 7. We would get 770 as before. And in a similar fashion, if we write 3 as a fraction of 10, we would have 3 over 10 times 1,100. Cancel 0 with a 0, multiply what remains in the numerator, and that would give us 330, which is just the same answer we get before. And once you add them back, you should get back the 1,100. All right, so that's a way to check to see if your shares are correct. You add them to see if you get back what it is that you share. All right, so with all that I've just gone through, guys, which we would have done from last class, then that would have covered all the areas that we're looking at in the ratio. Now, what we would like to do now, based on what we would have learned from last week, is I would like to go through these exercises with you. So I'm going to ask you now to quickly simplify these ratios in their simplest forms. As soon as you finish with exercise 1 or this part of the exercise, we'll move on to our next part and so on. All right, so just go ahead, simplify these, and then now, as soon as they're finished, we're going to walk through them together. So just raise your hand when you're finished doing all of these. All right, guys. So I'll give you probably about 5 minutes to do these, and then we'll move on. All right, so you may go ahead now. All right, guys, so are we making any progress with this question? How far are we now? Let me see the hands of those who are finished with at least the first 3 questions. Okay. Anybody else? Anybody else apart from Ms. Taylor? Would have finished the first 3 questions. Ms. Green, how about you?
Not finished as yet, sir.
Okay. All right, so as soon as you're finished, just raise your hand so that we can go through them quickly together, all right? All right, so we must at least finish question 1 and question 2, possibly up to question 5, you should be finished by now. All right, so expressing these ratios as fraction in their lowest terms. Now notice that they say express them as fractions. So if we're expressing them as fractions, it means that when we're writing the ratio, we write the left number to the colon over the right number. So in other words, here the 8 going to become the numerator and the 3 becomes the denominator. So this becomes 8 over 3. Now, to be able to simplify this, in its lowest term, we see whether or not there's any number to be cancelled with the numerator and the denominator. Can we cancel with 8 and 3? Is there any number can go into 8 and 3 without a remainder?
No, sir.
Right, so we cannot simplify this any further, so we leave it as is because we can't find any number that can cancel both numerator and denominator. For the second one, we would write 4/6. And then now we see whether or not we can find a number to cancel both numerator and